So we talked about these place value patterns and the movement with multiplication. Now we're going to talk division. And division gets a little more complicated because there are a lot of times in life we represent division as flip-flopped multiplication. So we're going to start with the base 10. We're going to start with the easy part. And then we're going to work our way into the patterning. So dividing in base 10. We're going to invert, right? I'm going to start with 400. $400 divided by 1. I'm going to go ahead and write these out because you guys have seen this pattern so many times. Shouldn't be too much of a problem. Wait, I don't have to spend my whole video on my knees. Look super awkward. 400 divided by 1. And I always phrase division in the form of money or pizza or something because to have that real life example of a thing kind of helps our brains wrap around it. If I have $400, if I buy a lottery ticket and I win $400, and I'm the only person who picked that number, that $400 gets divided amongst me, right? 400 divided by 1 means one person gets all 400. There's nothing extra to go around, right? Any number divided by 1 stays the same, just like any number multiplied by 1 stays the same, right? Represented as base 10 blocks. 4 groups of 100. Now, 400 divided by 10 is just another power of 10 thing. But instead of making it bigger by 10 times each time, we're making it smaller by 10 times each time. So instead of increasing, we're decreasing. I take this 100 and I take 1/10 of that. And I take this 100 and I take 1/10 of that. This 100, take 1/10 of that. And this 100, and take 1/10 of that. Make sense? Yeah. Now, to divide by 100, I'm going to get 2 place values smaller, or decrease by 2 place values. So it started as 100, now becomes a 1. 2, 3, 4. So, my answers start with 400, and every time I get 1 place value bigger in my division, or what I'm dividing by, my answer gets 1 place value smaller. Basically, I'm splitting it into more pieces, right? Splitting this into 10 pieces means each person gets $40. If we buy lottery tickets, 10 of us buy the lottery ticket with the same number on it. The prize was $400. We have to split it evenly. Everybody's going to get $40, right? Which is a lot less, 10 times less, in fact, but it's still a decent chunk of money. But if 100 of us buy a ticket with the same number on it, and the prize is only $400, all of a sudden we're getting like not even a $5 footlong from Subway anymore, right? we're getting about 5 inches of Subway, right? Not near what we were. Okay, now let's talk about this pattern, because this is where things start to get a touch complicated. I'm going to aim the camera a little bit better. We're going to look at this pattern in division, where we set up this problem in several different ways. This is 400 divided by 1. Or 400 divided by 10 to the 0 power. Now let's get weird. because multiplying and dividing by decimals gets weird. Inverse operation means flipping something around backwards, right? Flipping multiplication backwards gives you division. Flipping division backwards gives you multiplication. It doesn't mean doesn't mean everything breaks, right? Right? This is not earth-shattering or life-changing. So let me ask you a question that hopefully will help you visualize what we're talking about here. Do people in Australia know they're upside down?
No.
Australia's on the southern hemisphere. When I dribble a basketball, it goes this way, right? Down towards the ground. What happens when a person in Australia dribbles a basketball? Does it go this way or does it go this way?
It goes down.
No. If a person on the other side of the planet standing down here dribbles a basketball, it goes this way. Is this way up or down if you live in Australia?
Oh,
No, it's down.
Down.
Just because things got flip-flopped doesn't mean it doesn't still work, because here's Mr. G dribbling a basketball in North America. Here's Mr. G's buddy G'day mate in Australia. He's going to dribble a basketball. Now, because of gravity, everything is attracted towards the center of the earth, right? So just because we flip-flop things around doesn't mean up is down and down is up for this guy, does it? No, he's just dribbling a basketball and it's hitting the ground and bouncing right back up to him. It still works, even though we have to approach it from a completely different angle. Now, if we were floating around in space, we wouldn't be able to dribble it at all. Would we? So just because we're looking at things from a different angle does not destroy the fact that both of these people are still dribbling a basketball, correct? That basketball is still bouncing right back up to their hand. They're just approaching a problem from a very different angle. Here's the problem that I want to approach this angle from. We know multiplication and division are inverse operations. That means we take the same pieces and rearrange them to get the same pieces in a different order, correct? So what if I wanted to multiply to show this exact same relationship? I can't really do it with a 1, can I? $400 times 1 gives me the same thing, doesn't it? It does. So this isn't going to look real fancy the first time we try it. Well, that's messy. Can't be on YouTube with messy handwriting. These things all equal 400. Correct? We used our inverse operation, but it's still just a number 1. It's not super fancy, and you're looking at me like I'm from another planet. Which is fine, because I'm about to show you where this kicks in. When we move up a value, and we say 400 divided by 10, or 400 divided by 10 to the first power. We already know what our answer is going to be. We've already worked this out.
3 different times.
Like a million different times. This is literally a pattern we've been repeating since the beginning of the year. Let me bring decimals into the equation now. If I wanted to flip-flop this and say the same thing using a different operation, how could I turn this divided by 10 into a multiplication problem using a decimal? Try it. If you're not right, who cares? It is a different arrangement of 1s and 0s, right? Because we remember, we're talking on the number line. If here, this is our 1, we move this way, it's 10 times 10. We move this way, it's 1/10 of. We could say 1/10 of 400 is the exact same thing as saying 400 divided by 10. 1/10 of 400. Is 1/10 of 400 still 40? Yeah. 400, take away one place value. 400, take away one place value. 400, take away one place value. We just used multiplication of a decimal to do this exact same job as the division problem. Now, how would we show that as an exponent? Times 10 to the what?
First power?
To the first power moves it up 1.
To the negative first?
To the negative first power, yeah. 10 to the negative first power means take this 10 and inverse it. Instead of multiply by 10, divide by 10. My explanation may be a little off there because 10 divided by 10 is 1. But this means 1/10 of, because that 0 power means 1, right? So if we have 10 to the first power, that's 10. 10 to the 0 power, that's 1. 10 to the negative first power is 0.1, or 1/10. Starting to see that pattern take form a little bit? It'll kick. Here in just a second. All of these things, no matter what, equal 40. These are 4 equations that are telling you the exact same thing. 400 divided by 10 equals 40. 400 divided by 10 to the first power is 40. 400 times 1/10. Remember when we start looking at things from the other angle? Just because we flip-flop this upside down does not mean it doesn't work. It's just a different way of looking at the same thing. 1/10 of 400, 40. 1/10 of 400, 40. Now, when I write this out in hundredths, do you want me to stack them so you can see them a little better?
Yeah.
Okay. Yep, I look like a floating head. That's weird, but okay. Our first way of looking at this is just standard, right? 400, and we do our regular division. We're going to add one more value. 400 divided by 1 is 400. 400 divided by 10 is 40. 400 divided by 100, 4. The other way to show it, 400 divided by 10 to the second power. Also, 4. A 1 and 2 zeros. 4 divided by, what's 4 divided by 1?
40.
Take off the 2 zeros. Match it 0 for 0. This basically says, get rid of 2 zeros. 1 divided by 4 is 4. Now, what if we invert this? What if we take 400 times something to make it equal to a division problem? What number are we going to use?
Would be 1 and 100.
Yeah, it would be one, not 1 and, but 100th. That was a very good catch. 100th. This basically means divide by taking away 2 place values. 2 place values below 0. 2 place values up. 4. This is not something that kicks right away. I see a couple of people like, I'm not totally sure. This is not something that's going to kick in instantaneously. By the way, if you can't see around the computer, if you need to move, that's totally fine. This is something that it's a lot like riding a bike. When you first learn to ride a bike, your parents have the handlebars and they've got the seat, and they're like, look, you're riding a bike, and you're not riding a bike. You're sitting on a bike, and they're holding the bike up. But eventually they put you on training wheels, and once the training wheels kick, you just kind of go. This is one of those things. At first it's like, oh, this is so weird. And then all of a sudden you start working with it, and you start seeing the pattern, and you start writing your own numbers rather than just listening to me talk forever. And then you go, oh, I'm just adding and take away place values. 0 zeros. I'm just doing different numbers of zeros to match my problem. 2 zeros less. 2 zeros less. 2 zeros less. 1 0 less. No zeros less.
Okay.
So our 400 down here take our negative power of 10. So it's ones, tenths, hundredths. I moved down 2 place values. It's 4. So if we stack these problems, like they do in the book, you would see this. 400 divided by 1 equals 400. 400 divided by 10 equals 40, 1 0 less. 400 divided by 100, 4, 1 0 less. There are lots of different fancy ways they can arrange them, but it's not going to change that adding and subtracting or multiplying and dividing by powers of 10 is really nothing other than adding or taking away zeros. Because no matter what, the root of the issue is, when you take something times a 1 or divided by a 1, it's not going to change the actual digit. It's just going to change based on how many zeros are in the problem, how many place values are represented.